This is Mark Anderson for Kellogg Community College with the second part to our look at Chapter 1 and Section 3. What I want to do first is I want to take a look at the notation, and this is really important. In this function, this blue function over here to the right, we're going to look at the notation and be very specific about what it's asking. In Part A, this is asking what is the y value when x is 0, or what is the answer to f of 0. So what we're going to do is look at 0 on the x-axis. So 0 on the x-axis is here at the origin, so f of 0 is 0 on the y. And we're going to go to 6 on the x-axis, so this is going to be f of 6 is going to be 0 on the y again. Coincidence that they were the same. F of 2, so we're going to go to 2, is going to be negative 2 on the y. So f of 2, at 2 on the x, the y value is negative 2. And at f of negative 2 on the x, y is equal to 1. Is f of 3 positive or negative? So we go to 3 on my x. The function is down here, so it is negative. Is f of negative 1 positive or negative? Well, negative 1 on my x is going to be here on my function, so this is positive. It says here, for what values of x is the function equal 0? This is asking for moments where the graph intersects the x-axis. So of what values of x will the function be 0? That's in 3 locations. It's going to be at 0, right there, at 4, and at 6. So 0, 4, and 6. For what values of x is f of x less than 0? Or it's really asking, when is the equation negative? All right, so when is the equation below 0? Well, that is going to be between 0 and 4. So this gives us a quick chance to review set notation. And the set notation is when x is going to be between 0 and 4, but not including 0 and 4, because we want to know when it's less than 0. We don't know when if it was exactly 0, then we could put in these little lines underneath. But this is going to be less than 0 between 0 and 4. Now we're going to talk about the domain, and I've actually made a second picture of this here. So as I talk about domain and range of this function, we can, kind of check it out right here. Okay, so what is the domain of f? The domain of this function. So domain is our left and rightness, our leftness and rightness of this graph. So the furthest left it goes is negative 4, and the furthest right it goes is 6. So our domain are going to be the x values between negative 4 and 6. And the proper notation for this is going to be, less than or equal to. And the reason why is because these are solid dots. These are solid locations. So we actually get to negative 4 and we get to 6. The range is going to be the y values, and this is going to be our lowest and highest point. Our lowest point is at negative 2, and our highest point is at 3. So we're going to go from negative 2 to positive 3. And here's my, wow, that's there we go. Sorry that's written so poorly. This is y is between negative 2 and 3 on the range. So this goes from negative 4 to 6 domain, negative 2 to 3 on the range. What are the x-intercepts? Well, there are 3 x-intercepts here, and we answered that question above, but I'm going to write them as actual x-intercepts. That's 0, 0, the origin. The next x-intercept is 4, 0. That is the x and the y at that location. And then the third is going to be 6, 0. What is the y-intercept? That's the origin, 0, 0. And this is kind of fun here. This is how often does a line y equals negative 1 intersect the graph? Now, I'm going to change colors here and show you, let's see here, y equals negative 1. That is going to be a line that goes horizontally at negative 1. And pow, it hits that once right there. And pow, it hits that twice right there and keeps on going. So the answer to that question is going to be twice. Now, how often does the line x equals 1 intersect the graph? Now, that is a vertical line, and since this is a function, it passes the vertical line theorem, and here it is, pow, hitting that once and only once, and it better only hit that line once because it is a function. So the answer for k is twice. Let me turn on my pen. Twice, and this is once. Now it says here, for what value of x does f of x equals 3? So it's asking when does this graph reach 3 units high, and it does so right at that location. So the value of x is 5. So x equals 5. Now what value of x does f of x equals -2? So we look at the y value here. We're looking for x. Here's the y. The y is at -2, so x equals -2. All right, there's the first of 3 pages that we're going to finish up with in this worksheet here. I'm going to take care of this and move to the next page here. Okay, now what we get to do is determine whether the graph is that of a function using the vertical line test. And if it is a function, we're going to use a graph to find the domain and range, intercepts, and any symmetry. So in this picture here, let's first of all exclude any graph that is not a function. So of these 6 pictures, which one is not a function? And there's one of them, and it's right here. That is not a function because it fails the vertical line test. And the rest do pass the vertical line test. So let's just talk about domain and range. All right, now so this first graph is an exponential. So our domain, which will always be our x values here, our domain is going to be where x is going to be real. And the reason why x is real is because in an exponential function we can go to negative infinity and positive infinity because that's continuously going to the right and getting ever increasingly bigger. Now the range, though, if you remember your exponential functions, your range is going to be where your y values are going to be positive. You will actually never get to 0 in an exponential function. So here y is greater than or equal to 0. Of course, this is all like review from your Math 121 days. So if you have some questions, just look at my earlier videos on exponential domain and ranges. Now down here, we're going to take a look at some domain and ranges of this function here. And from what I can see, it looks like it starts at -3 and then goes on to the right. So here's my x, where x is going to be greater than or equal to -3. And it's a greater than or equal to because it is a solid dot there. My range is going to be y, and looks like it connects with 0 twice and goes to positive infinity. So x is going to be, or y is greater than or equal to 0. All right, now in this graph there were no intercepts, but in this graph there are. So there's an intercept at -3, 0. There's an x-intercept, a y-intercept at 0, 3, and another x-intercept at 2, 0. So again, some of these may or may not apply, and we haven't had any symmetry with these two graphs, but there might be some over here. The domain of this function looks like it goes from -pi to pi, and the negative got cut off a little bit on the worksheet, so it does go from -pi to pi. So let's draw that inequality correctly. And notice these are less than or equal to symbols because it is connected to these solid dots. Now the range here, the range looks like the lowest level is at -1 and the highest level is at +1. So therefore my y is going to be between -1 and 1. Spoiler alert, you will be seeing lots of these graphs in Unit 2, where we're going to be graphing sine and cosine functions. All right, now there are some intercepts here, and the intercepts are going to be -pi, 0. The origin is the y-intercept, and then we have pi, 0 for the other x-intercept. There is symmetry around the origin if you rotate this 180 degrees. This has 180 degrees rotational symmetry. So this would go to this side and that would go to that side. So there's some rotational symmetry for you. All right, so let's move to this next problem here. This is going to be another domain where we have x starting at 0 and going all the way to 4. So here we have x going between 0 and 4. And here is the y going between 0 and 3. So just more practicing with our set notation. And I'm going to avoid interval notation. I think set notation is more common for what the book uses. There's a intercept at 0, 0. There's no symmetry on this. If you reflect it and rotating 360 degrees is not everything's rotatable by 360. So it's just there's no extra symmetry in this problem. So far, this is the only problem that's had extra symmetry. As you'll see, this one doesn't have any symmetry either. It has vertical symmetry if you actually go through the line x equals 1/2, but not around the x-axis, y-axis, or origin. Okay, so finally here, it looks like we're going to have our domain. Our x's are going to be, well, you might say, oh, x is between -1 and 2, but actually not, because x is going to be infinitely big in both directions. So this is going to be, x is going to be real. And then we're going to go with our range here, our y values. It looks like it plateaus here at 5. So y is going to be less than or equal to 5 since it plateaus at a closed dot there. And there are 3 intercepts here. We have an x-intercept, which is going to be at -1, 0, a y-intercept at 0, 4, and another x-intercept at 2, 0. Okay, so for our final 2 problems, we're going to take an equation and we're going to actually ask some questions about it like we did with the picture on the other side. So let's scroll this down here a little bit. We're going to ask some questions about these functions, and what's going to come up here is maybe a little bit of review of some algebraic tricks and techniques that you used in Math 121. All right, so here we go. Start this off with, is the point 1, 2 on this graph? So what we're going to do is plug this into the x and this into the y and see if the equation is true. So 2 is equal to -3 times -1 quantity squared plus 5 times -1. So 2 is equal to -3 times +1, so -3, and then 5 times -1 is -5. So 2 is equal to -8. No. That is not. This is not a part of the graph. So at -1, the y value is not 2. All right. Now it says here, if x is equal to -2, what is f of x, and at what point on the graph of f? Well, this is kind of nice since we know that x is -2. What we will do is plug that in for x. So we're going to have our f of -2. And this is going to be -3 times -2 quantity squared plus 5 times -2. So with that in mind, what that's going to do for you, oops, got to turn that off. This is going to give me -2 squared, which is 4. So 3 times +4 is -12. And 5 times -2 is -10. So my answer at f of -2 is going to be -22. So what point is it on the graph of f? It is at the ordered pair of -2, -22. So our x value is -2 and our y value is -22. Now this is going to be a fun one because this actually is asking if my y value is -2. So if -2 is equal to -3x squared plus 5x, if this is the case, what are the points in f? And lo and behold, what we have here, if we move this 2 to the other side, is we have a quadratic formula problem. Or you can tackle this using factoring, but since you may be a little bit of rusty on your factoring, what I'm going to do here is bust out my a, my b, and my c for my quadratic formula and solve away. So this is going to be -5 plus or minus the square root of b squared, 5 squared, minus 4 times a, -3, times c, 2, all over 2a, so 2 times -3. So I've got -5 plus or minus. Now this is 25 plus 24 if you multiply these three numbers together. So this becomes the square root of 49, which is nice because that's an integer. So this is 2 times negative 3, which is negative 6. So now I have negative 5 plus or minus 7 over negative 6. Okay, so let's keep going from here. So I'm going to branch this off into two pieces here. So negative 5 plus 7 is going to be 2 over negative 6. And 2 over negative 6 is simplifiable to negative 1/3. So there's one of my two answers here. And the other answer, since this is a parabola here, we're going to have negative 5 minus 7, which is negative 12 over negative 6, which is going to be positive 2. So I have two answers to this problem. I have the answer at the y value of negative 2, I'm going to have negative 1/3 for my x, and I'm also going to have at my negative 2 for my y 2. So, pretty involved problem using the quadratic formula. Okay, now we're going to move to the back page, and on this back page I will write the equation here in this space up here, so you don't have to flip back and forth to try to remember what I was talking about here. So again, the equation is f of x is equal to negative 3x squared plus 5x. What is the domain of this function? Now, what's cool about this function is if you actually graph it, it has no excluded values, there's no denominators, there's no roots, the domain is real. All right, and you would see that it's a parabola, and it would go infinitely in both directions. Now it says here, list the x-intercepts, if any, of the graph of f. So what that means is that we want to know when does this hit the ground, and the ground is 0. So at what values of x does this hit the ground here? So what I'm going to do here is actually solve for x, and since there's an x and an x squared, I'm going to do a little factoring here. So I'm going to factor out a common term, which is x, which leaves me with negative 3x plus 5. And since this is set equal to 0, I know my two possible answers, x is equal to 0, and negative 3x plus 5 is equal to 0. So this is going to give me two possible answers for x-intercepts. Well, 0 is one of my two answers here, so there is an x-intercept at the origin. And then it says we're going to subtract 5 from both sides. Negative 3 is equal to negative 5x. And then we divide both sides by negative 3. So x is equal to negative divided by negative, positive 5/3. That's my second x-intercept at 5/3, comma 0. Now, it says for part f, which kind of ends our part of this problem here, it says list the y-intercept if there is one. Well, there is a y-intercept at the origin, 0, comma 0. That was kind of easy since the origin is the x-intercept, the origin is the y-intercept. We're going to do one more of these, and you'll have more in your homework, but I decided to only do this many, and I just can squeak this in on this page right here, so let's get started. For our final part here, it's going to say, is the point 1 3/5 on the graph of f? So my 3/5 is going to go in for my f of x, so that's going to be my y value, and my 1 is going to go in for each value of x. So this is going to be 1 squared plus 2 over 1 plus 4, which means that 3/5 is equal to 1 plus 2, which is 3, and 1 plus 4, which is 5. Bam! There it is. 1 3/5, or if you like decimals, 6/10 or 0.6, is at that location. The second piece of the puzzle is asking what is, if x is 0, what is the value of y? Well, let's kind of plug that in. Let's actually go do my f of 0 here and figure out where that is. So we're going to go with 0 squared plus 2 over 0 plus 4, which is 2/4, which is 1/2. So at 0 on my x, the height is 1/2, and there's my point on the graph. All right, now this is the problem. This is the part of the problem on the other problem that we did the quadratic formula, but this is a little different. It's saying like, okay, so if y is 1/2, what is my value of x? So I've got x squared plus 2 over x plus 4. Now here's what I'm going to do. I can do this with two fractions equal to each other. I can cross multiply. So I'm going to multiply these two together here. So distribute the 2x squared plus 4. And I'm going to multiply these two together. 1 times x plus 4 is just x plus 4. Now I'm going to move everything to the left-hand side and see what I get. So I'm going to move the x over here, so 2x squared minus x. I'm going to move the 4 over here as well, setting this equal to 0. And 4 minus 4 is 0, so now I have the equation of 2x squared minus x is equal to 0. Hooray! No quadratic formula necessary. I get to factor out an x, and I get 2x minus 1 equals 0. And now I have one of my two answers. X is equal to 0, and 2x minus 1 is equal to 0. I'm going to add 1 to both sides. 2x is equal to 1. Divide both sides by 2. X is equal to 1/2, and x is equal to 0. So my points are, oh, look at that. There's another, oh, shoot. I put the origin down here. I didn't mean to do that. I meant 0, 1/2, because we are looking at 1/2 on the x, so 0, 1/2. And for this one, it's going to be 1/2 on the x, 1/2 on the y. It is a coincidence they're the same. So remember, this is my y value here. So my y is 1/2 at these two locations, at 0, 1/2, and 1/2, 1/2. The domain, there is an exclusion here. There is an exclusion. You notice that the original equation does have a divisor, so therefore we are going to have to see when that x plus 4, we don't want that to be 0. But you can see that this is a simple step here, subtracting 4 from both sides. So our domain is going to be x, so that x is not equal to -4. There's our domain. It can be anything else but that. List any x-intercepts. This is a situation where we are going to try to see when we have 0 is equal to x squared plus 2 over x plus 4. So we want to see when this hits the ground. So when does this hit 0? Now the calculator would give this away, but let's actually do the algebra for it. We're going to crisscross multiply, so 0 times x plus 4 is just 0. And then we have 1 times x squared plus 2. And if we solve for x, we're going to move the 2 to the other side. -2 equals x squared. If we take the square root of both sides, we get an imaginary number. Therefore, there is no value of x that will ever be 0, so there are no x-intercepts. Nope. Now it says, list the y-intercept, if there is one, on the graph of f. So what that means is that if I plug my 0 in for x, what is my y value? And some of you looking up at the problem, you can kind of figure this out, but I'll do it in case you don't see it yet. So what I'm going to do is plug 0 in for my x and then figure out what my y value is. You see, it's right here, guys. It's right there. So we know that my f of 0, when plugging in 0 in for my x, this is going to give me the y-intercept of 1/2 here. So that is the answer to that problem for part F. The y-intercept is something we already found out earlier, and you can see that on the graph as well. All right, well, thank you for watching.